Okay guys, so welcome to part one. Today we are going to be going through the process of creating the rear wing geometry in SolidWorks. And that would involve downloading the coordinates from Airfoil tools. So we're going to start off. I've got my the selected airfoil that I want, this high lift airfoil. What I'm going to do is take these coordinates, copy, and open a notepad file. So I've got one open here. Just delete that. I'm going to paste that in. So these are the X and Y coordinates, which is okay, but for SolidWorks to be able to understand this notepad file, we need the Z coordinates as well. So I'm going to copy and paste all of that, open up a fresh sheet in Excel, just delete all of that. Okay, so what I'm going to do is I'm going to copy and paste in these coordinates. Don't know why that's happened, but let's just sort that out. There we go. Now it's split the data, the X and Y coordinates into separate columns, which is good. Sometimes this doesn't happen, and we have to force Excel to do so. So if it were the case whereby you had both data in one column, you'd select all the data. So you'd select all the data, like so. Then you'd head over to this data tab here on the ribbon. You'd head to text to columns. Okay, it's not going to let me. So you'd head to text to columns. Let's try that again. So you'd head to text to columns, make sure delimited is selected, head to next and make sure the space is selected. So that tells Excel that where there's a space between the data to split it into separate columns. Hit next and you'd press finish and then you'd have this. It's done it for us, so we don't need to do that. All we're going to do is add in a 0 there for our Z coordinates, because of course this is 2D. Copy that all the way down and we're done. So now I can go ahead, Control C, head back to my notepad file, delete all of that and replace it with this. Sometimes it does this here, you can see. Just ignore it, it's fine, it will still work. So that's that part done. So with that, we'd head into SolidWorks and we've got a new fresh part file here. Normal to front plane, and all we're going to do is insert, oh, before I do that actually, make sure you're using the correct unit. So head down here in the bottom right and change to meter, kilogram and second, otherwise you'll have a 1mm airfoil. So we're going to hit that. Head over to insert, curve through XYZ points, browse. So that notepad file that would have saved, just navigate to where that is. Make sure you're on text files here. So let's get my airfoil. Okay, so you can see the airfoil is here. Press OK. It's done. So that's all good. What I'm going to do now is import my flap airfoil as well. So curve again, curve through XYZ point. So I haven't opened a sketch, okay? You can't do this if you're already in a sketch. So navigate to where I've said my airfoil. So my flap is an E423. Open that. Okay, so I've got my two airfoils there. Now I'm going to start a sketch. Start a sketch in the front plane. First thing I'm going to do is I'm going to draw some construction lines through my origin. So I'm going to zoom right in, horizontal for construction, infinite length. This should just allow me to position things better or easier later on. So I've done that. Vertical for construction, infinite length through the origin. So we've got that coincident relation. So we zoom out. There we go. Okay, so we don't need to see these curves because we can't do anything with them. So I'm going to hide them. They're still there, I've just hidden them, as you can see. So I'm in the sketch. I'm going to select my main plane airfoil, curve 1, and press convert entities, okay? That's going to bring it into the sketch. So I've got what I want. Now we want downforce, not lift, so I'm just going to flip this airfoil over. So I've gone to mirror entities. I want to mirror about this horizontal plane. Hit OK. So that's good. Right. Got our first airfoil. Just going to move. Okay, so the first thing that I'm going to do before I do anything is I'm going to draw some tangents on the airfoil. So these tangents would allow me to position the airfoil more accurately or precisely. And they'll also help us define the slot gap geometries later on for the subsequent flaps. So the first thing I'm going to do is head over to line, make sure it's a midpoint line and it's for construction. Vertical. So this vertical tangent here is going to mark out the foremost point on the airfoil. So I've selected the midpoint line and the airfoil, okay? So you can see here line and spline. And I'm going to press the tangent relation, okay, to make sure that I know without a doubt that that's a tangent. It's at the foremost point on the airfoil. Okay, so that's that done. You can see I've got 4 relations here. I've got the coincident between the point or the midpoint of that line and the spline. I've got a relation between the midpoint and the line. The midpoint and the line. And I've got a relation between the midpoint line and the spline, which is a tangent relation. And finally, I've got that vertical relation here. I'm going to do the same again for the lowest point on the airfoil. So it's going to be a horizontal tangent this time. So horizontal for construction, midpoint. Click anywhere close to where you think is the most bottom point. Again, add that tangent relation. Tangent, there we go, that's that done. Now we need to do the same for the trailing edge. Now before I do anything, the trailing edge, I need to get rid of this finite point, because when we come to mesh later on, this point, the sharp edge, will create massive headaches for us in terms of getting a non-skewed mesh. If I try to have an inflation layer around this point, it's going to be highly skewed. There's going to be lots of numerical errors. The solution may not even converge, so it's just bad practice. Also, in reality, when we manufacture these wings, they're not going to have this finite, this sharp trailing edge. They're going to have some radius, because otherwise it'll be impossible to manufacture. So it is less than ideal in terms of the efficiency of the airfoil. This sharp edge is the most ideal case, so the wing will be less efficient. But that's a real life problem that the wing will suffer. So it will be useful for us to include it in the simulation to give us better accuracy. So what I'm going to do is I'm going to draw a circle, just a normal circle, okay? I'm going to give it a radius of 3 millimeters. So this diameter is going to be 6 millimeters, okay? Now, I'm going to position this in the airfoil. Doesn't matter where really, you'll see why. And all I'm going to do is hit tangent between the two, okay? And I'm going to just move it along until it's as close. So the tangent is here on this side until it's as close as possible to this edge, okay? Actually, I want the tangent on the bottom edge, okay? So just position the circle so the bottom edge is exceeding. Press a tangent. Okay, yeah, I've got it on the bottom edge now. And again, as I said before, just move this until it's as close to that edge as possible, okay? Next, I'm just going to draw a straight line from the spline to the circle. It can be rough, it doesn't matter. Head over to the Trim Entities tool, trim this away, okay? So we've got that. Then you're going to trim the inside of the circle. Okay, as you can see, we've got a rounded edge with that radius. So that's good. Now I'm going to delete it. This is the way that I found works. Been having a lot of issues with this step, but I'm going to delete it. Just the arc, not the entire thing. Yep, click yes. So we've got our open aerofoil here, and I'm going to dimension the aerofoil now. This is the sort of, this part is the least accurate in terms of the whole process. Delete this line as well, my bad. Okay, going to delete, and I'm going to smart dimension between there, make sure that it's you're dimensioning the chord and not just the horizontal distance. Okay, so we've got that. Now I want my main plane chord to be main plane 0.3 meters. Okay, so 0.3. As you can see, we've got that dimensioned nicely there. Okay, so now I'm going to do is head back to this open trailing edge, and I'm going to hit the arc, okay? Tangent arc. Select that first edge, then come round to the second edge. Okay, so you can see there's a bit of a discontinuity here between these two lines, but we can't dimension this twice. We can't tangent this twice. If I select the arc and aerofoil and press tangent, you can see it doesn't want it. The crucial thing is you've got the tangent on this bottom edge. This lower edge is important. That's where we're going to be getting most of our downfalls from. So just make sure the tangent is on the bottom edge and the bottom edge is smooth. Okay. So yeah, as we did at the front, we're going to add some tangents to that trailing edge. So for construction, again, midpoint, select anywhere there. Okay, so select the midpoint line and the arc. Tangent, I can see there's only 3 relations here, which means we haven't added the vertical. So they'll just add that there, we've got 4. That's that done. Do the same again here at the top. So you can see that's where I'm going to dimension the horizontal distance between the slot gaps will be done with this tangent, and the vertical distance with the slot gaps will be done with this tangent that I'm about to draw. So horizontal for construction midpoint. Let's draw that out. Make sure it's a tangent. Tangent relation. I can see I've got 4 relations there, so it should be horizontal already. Yep. Okay, we're done. That first aerofoil. All that remains now is to add the chord line. So line for construction. Go from that foremost point to the rearmost point. There we go. So you can see there'll be a slight difference between the actual chord and the one we've dimensioned here. However, that's necessary just to avoid the sketch breaking if we were trying to define the chord from using this line that we just drew. It would, some funny behavior happens between this line here. So, we've got the chord line. I'm now going to position the aerofoil as close to the origin as I can by adding a collinear relation between the tangents at the front here. So you can see now there it lies on the on that line there, and I'm going to do the same for these two here. So I've got the aerofoil nicely positioned there. So we have got the aerofoil dimensioned, we've got the tangents at the front and at the rear. What we can do now is we can define the angle of attack. So use that chord line that you drew and the horizontal. So I want mine at 6 degrees angle of attack. That's what I've decided. Okay, so that's that done. Okay, so we've got our main plane set up. We've got it dimensioned. We've got the 6-degree angle of attack. We've got our vertical and horizontal tangents everywhere. Let's try our flap. Let's try our flap element now. So what I'm going to do is, remember the flap is still there. It's curve 2. It's going to select that and press convert entities to bring it into the sketch. Okay. Again, mirror it, mirror entities, select the flap, aerofoil, mirror about, horizontal. Okay, that's that done. I'm just going to move it over here, make it a bit smaller. Okay, give us something to work with. Okay, so from this, same as before, let's add our tangents at the front. For construction, midpoint line. Let's do the vertical one first. That's that. Tangent it. Done. Same again. Horizontally. For construction, midpoint. Okay. Tangent that. And we are good to go. And now, same again. 3mm radius circle. 6mm diameter. You want to place this and then add the tangent. Select the circle, the airfoil. Tangent. There we go. Now, same as before. Move in as close as you can get it. It's pretty good. Join the two up. Trim. Trim entities. Get rid of that. Get rid of that. And now delete. And delete that little line that you drew as well. So we've got the arrow for the open trailing edge now. I'm going to dimension it now. So from that midpoint to that open edge there. So I want my flap chord to be flap 1, 0.18 meters. 0.18 meters. Got that dimensioned. Good to go. Okay, so next we're going to head over to the tangent arc. And again, just draw that tangent, make sure the tangent's on the bottom edge. You can see, contrary to before, we haven't got this that big discontinuity between the spline and the arc. It's a lot smoother now for this E423 airfoil, so that's just what we want. Tangent on the bottom edge, the lower surface. So I'm just going to go ahead and add my and my tangents. So midpoint for construction, let's do the horizontal one. Tangent's already there. Just make it horizontal. There we go, fully relationed up. Vertical for construction, midpoint. On the arc. Now let's tangent it. That's that done. Make it vertical. There we go. Now let's get our chord line drawn for construction. From that edge to there. So we've got our chord line, and now let's set the angle of attack at 30 degrees. Okay, so this is good. Let's move this airfoil over here. Let's move it a bit closer because now we're going to define our slot gap geometry. Okay, so where's that horizontal tangent gone? Is it still there? Okay, it's still there. It's just very small. Let's make that a bit bigger so we can see it. Okay, so I'm going to define the horizontal slot gap now. Let's just go from this tangent to this one. And let's say I want it at 12 millimeters, right? Let's just bring that in there, and I'll do the same for the vertical slot gap. So from that tangent to this tangent. Okay, bring that in 12 millimeters. There we go, we've got our multi-element airfoil. So, a couple more steps to go. Let's just double check, we've got 30 degrees, 6 degrees. Chord lengths all dimensioned up. Let's clean up the sketch a bit. Bring that chord length in there. That horizontal distance there, that horizontal distance there. Okay, so we are now in a position to start saving this. So before I do that, I'm going to exit the sketch. Okay, so that's all in sketch 1. I'm going to open a new sketch. Open a new sketch in the front plane. In the front plane, sketch 2. I'm going to convert the entirety of sketch 1. Okay, so select sketch 1, convert entity. And you can see that brings it in minus all of the dimensions and relations because they're fixed. We don't need to change them. So that's now all in our new sketch. Now the crucial step to go to insert, surface, planar, current sketch, click hit OK. So there's our airfoil. This is now in a position where we can save it. So we'll head to File, hit Save. Of course, if you had a triple element wing, you'd just do the same again for that third element. Just copy the whole process over again. So I'm going to say this is tutorial. Have the part file saved. Just save it as a part file in my directory. Just for reference, if you need to go back and change anything, you can just go back to sketch 1, do the same, do your changes, make a new sketch and then convert entity into that new sketch, and then make your surface. So I've saved it as a part file. Now to be able to import it into ANSYS, I need to save it as, head to save as, and then save it as the IGES. Okay. So save that, and then when you head into ANSYS in the next part of the series, you will be able to import it in. So yeah, that's it for today.